Hey, this video is on the Turing halting problem. Now, I may have probably should have done this in the last video, but nonetheless, it's important to know what the Turing halting problem is because that is also important to the theory of computation. Now, what is we talked about before? The Turing machine consists of the head, the tape, the state register, and the table. Now, and of course, is the model for the typical model used for computation. Now, what exactly is the Turing halting problem? It's basically where well because the Turing problem stops after a certain amount after the computation is done. Now, however, there are certain problems which it will it will continue to try and find an answer to, and it'll run with it forever. So like, will the Turing machine actually halt, or will it loop forever, or what exactly decides this? Now, if you guys watch my video series on set theory, I talked about Kurt Gödel's incompleteness theorem. Now, what that is there are some statements which are true but cannot be proven to be true within the axioms of that system, which simply just means that you're not going to always be able to prove everything in math and logic. So, and the Turing machine is no exception because Alan Turing, as I said before, he used Gödel's work in his own work, and so he said, if formal mathematical systems, follow this procedure, then what computers which are logical and mathematical must also succumb to this problem. And so here it is. Let's say we have like if x is true, then let's say the transition function is outputs x again. Now, will this is the Turing machine gonna stop here, or is it gonna continue to do this repetitive transition function over again? Because x is gonna be true, and if it's true, it's going to keep transitioning to this X state, looping itself forever and ever. That's sort of what it's about. So that's some problems are deemed incomputable, which again I think I said in the last video was where it takes an infinite amount of time to solve, which is just defined to be incomputable because you can't really compute that. And so yeah, Gödel's incompleteness theorems definitely apply to computer science, and that's sort of what the Turing halting problem is all about. All right, that's it for now. See you guys in the next video.